Hello, today I'm going to be teaching you one-dimensional kinetics. So for this introduction, I'm going to define what is one-dimensional kinetics. One-dimensional kinetics refers to the position and movement of an object as a function in time in one dimension. We almost remember it's one dimensional. And kinematics is the study of motions and how to mathematically describe it. And well, in this case, it's going to be one-dimensional. Later on, it will be a lot more complex, and two-dimensional, three-dimensional, and so on and so forth. And in my opinion, one-dimensional kinetics is arguably one of the most basic units. However, it's the most important unit in physics because later on, whatever you're going to do with physics, you're going to come back to the stuff you learn in one-dimensional kinetics. No matter what you do, actually, you're going to come back to this and you're going to use it again. Now, so before we're going to start looking at some of the more important formulas, we're going to look at some of the key definitions. So first, position. Position is a location. And in a question or problem, it usually doesn't assign us with a coordination system. So we can't really decide on a position at that point or a location. So we have to create a coordination system of our own. It could be a Cartesian plane, or in this case, really the easiest way is to be a number line because it's one-dimensional. And always make your life easier because you will need it. Later on, the question could get a lot more complex, a lot larger. So try to make your life as easy as possible. Position, as I said, is a location. Distance is the measurement of length. And it's actually somewhat of a unit and a measurement of length. And then we can talk about distance between 2 points or the distance traveled. And then this is really just distance. However, these two things I said are a bit more different from each other. Displacement. Displacement is the change between the start and end. So start and the change between start and end. And it's important to remember that displacement could be positive or negative, whereas distance could only be positive. So we can say that he displaced -9 units or -7 units, whereas distance, he's always 7 units from where he started. Speed. Speed is how fast something moves, and it's basically distance divided by time. And then speed always is positive. Velocity, on the other hand, is different because velocity is speed with a direction. So velocity can actually be negative. And so this velocity is positive or negative. And then you can use the same formula for speed. Acceleration or constant acceleration, it's the rate at which the velocity changes, and the change in velocity is divided by the time it evolved, which is acceleration. So in this case, say we started from 3 km/h, and then you increase to 5 km/h in 2 hours. So what this would look like is you have change in velocity, which is 5 - 3, over, well, the time, which is 2 hours, and then you would get, so that's 2 per, so that would be 1 km/h. Delta just refers to change in, and it's actually a Greek capital letter. And say, if we want to say change in velocity, I would just be delta V. And delta is always very important to remember. Formulas. Now we're getting to the juicy parts. But of course, before we're talking about a formula, I think it's always important to talk about some of the things you're going to see in a formula. So delta X is usually refers to the displacement. T is time, travel, I can't spell. Velocity 0 is going to be initial velocity. V, and then V is going to be final velocity. And then we have A, which is acceleration, which is actually fairly simple. Now we got these out of the hand. We also going to indicate what gravity is, because in a question, gravity is usually very important in a free fall question. Say some object is dropped from a tower or dropped from a cliff or something of the sort. And we just need to remember gravity is negative 9.81 meters per second, and it's negative because it's an acceleration. And it's always pointing down. So you must remember gravity is always pointing down. It can't point anywhere else. And it's pointing down basically means that it's pointing towards the floor. Now we're going to talk about some of the formulas you're going to use. So looking at these and your approach with the question, if you're missing, say, delta x, which is the displacement, then you can use this equation, which is velocity is equal to initial velocity plus acceleration times time. And this is basically how you pick it. You will look at the question and you will say, what's missing? If it's missing displacement and it has the rest 4, then you would basically use this, because this is the only one you can use. And you would say the initial velocity is going to be equal to the final velocity is going to be equal to initial velocity plus the acceleration times time. So let's say what this would look like is the question is asking us, what's the final acceleration, final velocity? We know that the initial velocity is 2 kilometers per hour, and then we know that the acceleration is 1 kilometer per hour, and then it went on for 2 hours. Then we know that it's 2 kilometers per hour is the acceleration, and then this is 2 kilometers per hour, carrying it down. And then we would know the final velocity is going to be 4 kilometers per hour, which is often very helpful. And then now once we're done talking about this, I'm going to talk the second equation, which is going to be if a question is missing acceleration, then we can look at this. Change in x, or delta x, which is displacement, is equal to final velocity plus initial velocity divided by 2 times t. So the question could be asking you, well, what's the displacement between 2 points, say point A and B? Then you can say, well, this is the velocity. So we then have the initial velocity, which is 1 kilometer per hour plus 2 kilometer per hour. So here we actually see that it's slowed down, divided by 2 times t. So now then we'll say this is 3 kilometers per hour divided by 2, which is equal to 1.5 kilometer per hour. And then in this case, how about we say t is they moved for 2 hours, and then we would know that they actually moved at a 2h. So now these h actually cancels out, so then we would know that it's actually 3 kilometers. So it's always helpful if you write down the units, then you would see that 1.5 kilometers divided by 8, so the displacement can't be per hour, and it has to be a distance. So that's why you have, if you're writing h, you would then clearly see that, well, that's clearly cancels each other out, and you would be left with 3 kilometers. So now we know that if the person started traveling at 2 kilometers per hour, slowed down to 1 kilometers per hour in a matter of and it traveled for 2 hours, we know that they moved for 3 kilometers in total. So this is also extremely helpful. And as I said, if you're missing acceleration, then this is your go-to formula. Then now we have a formula which is missing the final velocity. So now it gets a bit more complicated. It's delta x, or displacement, is equal to initial velocity times time plus half of acceleration times time squared. So this gets a lot more complicated. Say we want to find the displacement, we want to have velocity. So let's say the initial velocity is 1.5 kilometer per hour times 2 hours, and we're writing the units to help us understand. Plus half of acceleration, let's say accelerated for 2 kilometers per hour times 2 hours, because in this case, we must see that t is always the same thing. So the time is always the same thing unless indicated otherwise, squared. And then we would go on and solve this, and then we would find what's displacement using this formula. Erase this. Now we are going to look at the final equation, and which is if it's missing time. So we're going to say final velocity squared is equal to velocity squared, and its initial velocity in this case plus 2 acceleration over delta x. Sorry, not over times delta x or displacement. And then we would then input what or insert whatever we know. Say we know initial velocity, let's say 1 kilometer per hour squared plus 2 times acceleration, let's say 2 kilometers per hour, changing distance, and that would just be, let's say 5. And then this is going to be velocity squared. So then we would just solve this, and then we would find what velocity really is. So these are some of the most important formulas you're going to use and you're going to see. And later on, I'll also be making a video on how we derive these very important 4 formulas we're going to use. So how they're derived, and then I'll also be posting the video on some of the questions and then a video on answers. So thank you for watching, and thank you, of course, for listening. Have a lovely day.